Trigonometry is the branch of mathematics that deals with the relationships between the sides and angles of triangles and the relevant functions of any angles. We can use trigonometry to find the sides and angles, most specifically in our case, of right triangles. Other applications of trigonometry can be used to find other sides that are not part of right triangles. To start with trigonometry, we look at the right triangle. A right triangle is any triangle that has one 90-degree angle. The opposite sides do not touch the angle. Opposite sides and adjacent sides will become very important. So if I look at angle A or B, so the non-right angles, these are going to be the most important angles in the right triangle. Opposite sides are directly opposite. They're across from the angle. We've discussed the relationship. The biggest angle is across from the biggest side. The smallest angle is across from the smallest side. These are opposite sides. Adjacent sides do touch the angle. If we're looking at angle A, side B is the adjacent angle or side. It's the side that touches it. If we're looking at angle B, side A is the adjacent side. It's the side that touches it. The hypotenuse, or in this case side C, is the longest side. It's always directly across from the right angle. Even though side C touches angle A and B, we would not consider it adjacent because it has a very specific name, the hypotenuse. One simple and common relationship between the sides of a right triangle is called the Pythagorean Theorem. If we have two of the sides, we can always find the third side. Using the formula a squared plus b squared equals c squared. It's a matter of knowing what those two sides, the two base sides, a and b, or the legs they're sometimes called, and the hypotenuse, c. You must use square root to solve. If I know a and b, I can solve for c. If I know a and c, I can solve for b. If I know b and c, I can solve for a. The angles do not even come into play when we're dealing with Pythagorean's theorem. Let's look at an example using Pythagorean's theorem. Always start by writing out the general formula. A squared plus b squared equals c squared. We have two of our sides. Now it's not the hypotenuse. The hypotenuse is always c. Here I have a and I have b, so I'm going to plug those in. 4 squared plus 3 squared equals c squared. So I'm going to simplify or evaluate 4 squared and 3 squared. That's going to give me 16 plus 9 equals c squared. Now this is where a lot of students stop. A lot of people say, oh, 25 is my answer. That side must be 25. Now the hypotenuse is always the longest side, but 25 is a much longer side than one would expect for a problem like this. That alone should be a reminder that you need to take that square root. I'm looking for c by itself, so I need to take the square root. Square root of c squared is just c. Square root of 25 is just 5. So that means my missing side, or my hypotenuse, is 5. This is a very common right triangle, a 3, 4, 5 triangle. You may also see multiples of this. You may see a 6, 8, 10 triangle, a 9, 12, 15 triangle. So as long as it's a multiple of 3, 4, 5, you can find that third side very easily. If I know that my hypotenuse is 5 and one of my legs is 4, the other leg automatically has to be 3. If you aren't given two sides, for example, you might be given an angle and a side and asked to find a third side, you need to start using your trigonometric ratios. The first of these is sine. Sine is the ratio of the opposite side over the hypotenuse. Hypotenuse is always the longest side, the side that's directly across from the right angle. The opposite side always is based on the angle that we're talking about. So if I'm talking about the sine of angle B, the opposite side is B. It's straight across. It's the side that the angle is not touching. C is always the hypotenuse. It's directly across from the right angle. So I would set up sine of B, the angle, equals B over or divided by C. Depending on what we're solving for, B, or uppercase B, could be a variable. Lowercase b could be a variable. Lowercase c could be a variable. If I was finding angle A or given angle A, the sine of angle A represents side A, which is directly across from angle A, divided by side C, which is the hypotenuse, directly across from the right angle. The next trig ratio that we deal with is cosine. Cosine is the ratio of the adjacent side over the hypotenuse. The hypotenuse is still the longest side. It's still that side that's directly across from the right angle. In this case, it's represented by side C. The adjacent side is the angle that the side that touches the angle. So if I were to find the cosine of angle B, it would be A divided by C. A is the adjacent side. It's the side that's touching angle B. C is the hypotenuse. That does not change. The hypotenuse is always the same side. It's always directly across from the 90-degree angle. If I was going to find cosine of angle A, I need to find the ratio of adjacent over hypotenuse. So the adjacent side here is B. The hypotenuse is still C, so I get cosine of angle A equals B divided by C. Tangent is our third trig function. Tangent's the ratio of the opposite side over the adjacent side. Opposite is the side that is directly opposite the angle or the given angle. This is the side that it is not touching. Adjacent is the side that it is touching. So if I was going to find the tangent of angle B, B is directly across from it, A is touching it. So tangent of angle B equals opposite B divided by adjacent A. Tangent A, it changes. So the tangent of angle A is equal to A, which is the measure of the side directly opposite the angle, and B, the adjacent side, which is touching the angle. We can remember these trig functions by using the saying SOHCAHTOA. SOHCAHTOA tells you the ratio of all the trig functions. This not only tells you how to set up the trig function, but it explains how to figure out which trig function you're going to use based on the given and unknown sides. So the first one, sine, is the ratio of opposite divided by hypotenuse. So if you're given a problem where you are given either the opposite or the hypotenuse, and your unknown is either the opposite or the hypotenuse, you're going to use sine. C stands for cosine, which is the ratio of adjacent over hypotenuse. So if your problem has two sides, one given, one unknown, and they are the adjacent and hypotenuse based on the given angle in the problem, you're going to use cosine. Tangent is TOA, which is the ratio of opposite side divided by the adjacent side. If you're given a problem that has two sides, one given, one unknown, you're going to end up using tangent if those two sides are opposite and adjacent relative to the given angle. Remember, opposite and adjacent changes based on which angle you're looking at. Let's solve for a missing side. In order to do this, we need to look at our problem and first determine which trigonometric function the problem represents. We're going to write this trig function with the given angle. Our given angle in this case is 33.06 degrees. We're given one side, 5.4, and another side is unknown. Based on this angle, 33.06, I need to determine what the relationship is to these sides. Well, directly across from C, directly across from our right angle, is the hypotenuse. So my unknown is my hypotenuse. So I need a trig function that deals with the hypotenuse. Directly across from my angle, so the side that it's not touching, is the opposite side. So I have opposite, I have hypotenuse. So ka, toa. So I'm going to be dealing with sine. I'm going to have sine of the given angle. I decided on this ratio because sine is so. S is sine, O is opposite, H is hypotenuse. So I'm going to set up that relationship. Opposite side, which is 5.4, over the hypotenuse. I use the given sides to represent the trigonometric ratio. Represent an unknown side with a variable, so I know my opposite is 5.4. 5.4 divided by my unknown side, which is my hypotenuse. Last step is to solve for the variable. In this case, you will need a calculator. It's impossible to do these problems without a real non-cell phone calculator. So I could set this up and actually set this as cross multiplication, or know this shortcut. If I have my trig function set up like this, and x is in the denominator, I'm going to switch out my trig function, sine of 33.06, and x. When I switch those out, I end up with x equals 5.4 divided by sine of 33.06. You could go through the cross multiplication process to get there, or just know this shortcut. Now I need to use my calculator. I'm taking 5.4 divided by sine of 33.06. Your calculator, when you type in sine, it opens a parentheses. After the parentheses, type in 33.06 and close your parentheses. Make sure that if your answer does not match our answer, that you go back and first make sure that you wrote out your work correctly and typed it in your calculator correctly, but also make sure that you are in degree mode in your calculator, not radian mode. 5.4 divided by sine of 33.06 in my calculator gives me 9.89. So that means that the measure of this missing side, the hypotenuse, is 9.89. A couple of tips that may help you as you solve these problems. Sometimes it helps to write SOHCAHTOA slightly different. So, ka, toa. The big letters represent the trig ratios, sine, cosine, and tangent. The ratios represent the trig ratios, opposite over hypotenuse for sine, adjacent over hypotenuse for cosine, opposite over adjacent for tangent. Here's a couple calculation tips. If the variable's in the denominator, switch the variable in the trig function, then calculate. We saw this shortcut already once. This is when your unknown is the denominator of your ratio. Switch them out and then divide your numerator divided by your trig ratio with the given angle included. If the variable is in the numerator, multiply both sides by your denominator. This will cancel it on whatever side your variable's on, leaving you with just your variable, just your unknown by itself, and it will calculate the missing side when you multiply the trig function times that other value, that denominator value. Let's try another example together. In this case, we have an angle of 55.05, that's angle V. We have one side that's 5.8, and then we have an unknown side. I need to figure out what those sides are so I can figure out what my trig function is. 5.8 is directly next to that angle. It's touching angle V. So that is an adjacent angle, or adjacent side. Directly across from angle V, the side that it cannot touch, is the opposite. It's unknown. So I have an opposite that's unknown, adjacent that is 5.8. So I have opposite and adjacent, that's TOA, tangent. So I'm going to take tangent of 55.05 degrees. Then I set up my ratio. Opposite is unknown, my adjacent is 5.8, and then I just need to solve. In this case, my variable's up top, I'm going to multiply because I'm solving a one-step equation here. What's happening to my variable? I'm dividing by 5.8, so to solve, I'm going to multiply both sides by 5.8. If I do that on the right, it cancels things out. Now be careful, when I'm typing this into my calculator, I'm not typing 5.8 times 55.05, I'm typing in 5.8 times tangent of 55.05. So when I type all that in, I get a final answer of x equals 8.298. In this case, you could round to 2 decimal places. I chose to round to 3 because of the way this particular value rounded. However, that's what that side represents. We chose the correct function based on the given sides and unknown sides. We used those given and unknown sides to set up the ratio on the other side of the equation, and then we solved. Since the variable was up top, we multiplied both sides by our denominator. If the variable was down below, we'd switch out the variable in the trig function like we did in our first example, and we would then divide to get our answer. On your own, give these two problems a try. Set up the trig function, set up the trig ratio, solve for the unknown value.